Hello and welcome back to your own channel Indian Defense Analysis, where we bring to you all the latest development happening in the defense sector.
The Project 75I is Indian Navy's follow-on of the Project 75 class submarine, under which Indian Navy is building the Kalvari class submarines at Masgaon Dock Limited in Mumbai. 4 of the 6 Kalvari class submarines have already been inducted. The fifth one, that is Vagir, has entered sea trial, and last one, Vakshir, is under final stage of development. Back in July last year, MOD has approved 43,000 crore for Project 75I, under which 6 conventional submarines equipped with air-independent propulsion will be indigenously built. In July 2021, the MOD formally issued an RFP for the construction of 6 designated submarines worth Rs 43,000 crore under a strategic partnership model. MOD had selected Majgaon Docks Shipyards Limited and L&T as shipyards who will build the selected submarine design. The two Indian shipyards would have to collaborate with shortlisted OEMs who are competing in the project, which includes Russians Rubin Design Bureau with Amur 1650, France Naval Group with a conventional Barracuda design, Spain's Navantia with the S80 Plus, Germans TKMS HDW 214, and South Korea's DSME with DSME 3000. As a part of the Project 75I, Indian Navy is looking for a proven AIP system. Only 2 out of 5 OEMs have a proven AIP-based submarines, which are Germany and South Korea. The AIP are of many types, and the one required by Indian Navy is fuel cell-based AIP. Spanish Navantia is also constructing their latest S80 class submarine with fuel cell-based AIP, but it is not operational yet. French Naval Group has MESMA based AIP, and there is no confirmation of Russian fuel cell based AIP. Last year, it was reported that Germany's TKMS had sent a letter to government citing 3 major reasons for withdrawal from the contest. Company highlights the rigidity of RFP, short timeline, liability clause, and degree of transfer of technology. As per the latest report from Economic Time, Russia has also decided not to participate in the bid due to technical reasons, which leaves only 3 OEMs participating, with only South Korea having proven fuel cell-based AIP system, which also has concern about the transfer of technology. In summary, the Project 75I is facing roadblocks and delays with foreign OEMs over fuel cell-based AIP, transfer of technology, and other technical reasons. On 8 March 2021, DRDO has demonstrated AIP system on a land-based prototype developed by the Naval Materials Research Laboratory of DRDO with support of industry partners L&T and Thermax. The plant was operated in endurance mode and max power mode as per user requirements. The DRDO's fuel cell-based AIP uses phosphoric acid as an electrolyte that reacts with hydrogen generated from sodium borohydride and liquid oxygen to generate electricity. The DRDO fuel cell aims to give endurance of up to 14 days to a conventional submarine. The 270 kilowatt fuel cell based AIP system will begin to be fitted on the Scorpion submarines. The DRDO's Assure AIP system version has to be redesigned before it is ready to be fitted on the Kalvari class submarine in 2023. The redesigned version will then undergo sea trials for testing various parameters, including performance and endurance. The best way forward for the Project 75I is to go ahead with French Naval Group with the provision of DRDO's AIP. The submarines cannot stay hidden forever. It must eventually come on surface somewhere to safely recharge and reload fuel and oxygen. AIP gives a small tickle charge to constantly top up the submarine's battery, but not enough to fully charge it up like the diesel engines. However, it is enough to slow down the battery drain. With AIP fitted submarines, the charge in battery can last up to several days or a week when compared to non-AIP based submarines where the charge lasts only for 15 to 20 hours. A typical conventional power plant provides 3 megawatts maximum and an AIP source around 10% of that. AIP does not normally provide the endurance or power to replace atmospheric dependent propulsion but allows longer submergence than a conventional propelled submarine. AIP is usually implemented as a supplementary source of power, which works with traditional diesel engine handling surface propulsion. Most such systems generate electricity, which in turn drive an electric motor for propulsion or recharges the submarine's battery. AIP can be retrofitted into an existing submarine hull by inserting an additional hull section.
This was today's update. Please let us know what is your views about these in comment section. Feel free to post your comments and suggestions about any topic related to defense sector on which you want to hear from us. With this, I would like to say goodbye and Jai Hind friends. Please like and subscribe our video if you have not done already. We will be soon back with more interesting and amazing development happening in defense sector.